Welcome to this session. My name is Letizia Ferrara, and I'm working as Senior Application Engineer in the Low Frequency team at Altair. So today I'm going to present you the new feature, and I hope you enjoyed the presentation and that it convinced you to use SimLab interface, the SimLab interface for your future electromagnetic studies more and more. So as you can see, the list of the new things to see is quite long. So, and we only have 10 minutes. So please write your question in the chat. We will answer them at the end of the presentations. So the first new feature we want to present is the 3D CAD-based workflow. So this new function extends the parametric capabilities to the 3D geometries. So the user can perform DOE studies within SimLab or export the models for hyperstudy without scripting. So the feature is essential for replacing the Flux functionalities and offers a valuable tool to perform design of experiment and optimization. You can see the workflow starts to the parametric can start to the sketcher, so where user can draw their devices. In this case, is a motor, so in 2D, and then continue the setup of the model in a single interface. So a short video can show the new capabilities, we set up a motor model within SimLab, starting from a sketch, and geometric parameters are available in the parameter browser. So the solution contains the bodies and the model is ready to be solved. You can see all the physics that is set up. As example, the height of the motor will be easily changed, as well as the air gap length, and the model can be solved just after. So without any operation in between, just some click to have the new results. The user can decide which kind of workflow you want to use, entering the correct entities directly in the solution, so CAD or mesh. And to differentiate the CAD-based workflow and the mesh-based one, ribbons will be different in the two cases, especially for the meshing that will be set directly in the solution with the new CAD-based workflow. The second improvement is related to the EM mesh tool, originally developed as SimLab's added mesh and commonly used by all the Flux users. So the EM mesh has been announced to support now tetra, hexa, and wedge elements. So this should allow the user to have more freedom in meshing. The next feature can be considered as solution updates. Finally, the magnetic chassis solution is now available also in 2D that allows the user to speed up the solving, considering sinusoidal quantities in the domain for induction motor and induction heating cases, for example. In this regard, the squirrel cage component is now available to simplify the circuit design in case of induction motor. You can see the new component available in the list. By using the solution coupling technique in SimLab, we can now initialize a transient solution with a magnetic C1 solved in the same model, so without complex exchange between different models. This can be very useful for induction motor application, for example, in order to reduce the number of electrical cycles to consider to reach the steady state working condition. So also yaw losses are very important, especially for the cases we just discussed because of the raised temperatures in the device. So SimLab now offers the one-way coupling between the new magnetic chassis solution with the flow solution to better evaluate the mean temperature staying in the same model. And the flow solution has AcuSolve background and can be used in 3D for accurate understanding of the heating or cooling process, depends on the needs. And also the two-way coupling between Flux solutions and flow ones is available, so to increase the level of accuracy in computing of spots. Different options are available. You can see the steady state and transient domain. So while considering that solving times may be important if a domain is chosen over the time for both solutions. So increasing the accuracy, solving time can be increased, but we know. Thin region can be also used now in a magnetostatic 3D solution to represent, for example, an air gap region or a magnetic non-conductive one. You can see an example of a ship where the surfaces, the around surfaces, are modeled. And so the model can be simplified, avoiding to represent the thickness of the volumes, so of the thin regions. So moving to specific application, we improved the workflow for Altair Flux machine, adding an automatic test type. The first one is the cog-in-torque. New type will be added in the future. So user can define the parameterized geometry using the dedicated template already available and easily perform a test. We have a short video for this. So you can see the template, you can choose the Altair Flux motor, and you have the test type now available in the solution. Entering the values and clicking on OK, the macro starts. So you will have the parameterized motor model, and also the physics is already set it up. So then to solve the model, user can modify LBC in case, or just click on results, update to solve the model. Yeah. About magnetic materials, we added 346 new materials type in the built-in database. So new materials model and new material models are available to better represent the real behavior. So of the device. Analytical model with saturation. We added the analytical model with saturation option for soft magnetic materials, and also the thermal dependency. And for hard magnetic materials, the nonlinear model with knee adjustment is now available. So is for sure a big improvement. Advanced boundary conditions are also available considering extraction, for example, in 2D. You can see the position now that is defined as extraction, depending on other parameters, so frequency and time, as we was used to do within Flux. So by popular demand, the Flux solver settings are also visible in the SimLab solution and can be changed. User can set the initialization type and the linear and nonlinear solver to use in the simulation. So this is a very big improvement also. Switching to the post-processing stuff, new responses type are added. So user can request for max and minimum value, or predefined global responses, and decide the time interval or the angular steps. So we also have a new solution. So this is another new solution is the VIM, so the volume integral method that is added to SimLab. It is useful to speed up magnetostatic problems, since the area around should not be meshed. In fact, the volume integral method can be used for different applications that we are going to see. The main plus is that only active region should be meshed, so coil, iron core, and magnets. Typical application for this new solution available in SimLab for example, a current sensor, the loosely coupled transformer, and the inductive power transfer system. So you can, if you have some of these applications, you can test the new solver. About integration with Flux and Flux motor, so we improved the reading of the Flux models within SimLab. My colleague Abda Samad will speak more about this in detail. And we finally have the possibility to create outer slot part for a flux motor. So starting from a catalog, user can choose a part, edit it, and export the part to use in flux motor. So parameter can be considered, and this should replace the flux, the workflow we have within Flux at the moment. So just to conclude, don't miss to visit the SimLab Learning Center. You will find updated examples that can help you to understand, to start, with your application case. And most of the examples already contain the CAD-based workflow, so don't miss it. Thank you.